I think our lives need to go to English class. That's actually
English is my second language. English is my second language, so we don't cry.
Okay, when you take the derivative of y stuff, you take the derivative,
dy.
and then you have a dy dx at the end. Okay, so you'll take the normal derivative, but then you'd have a dy dx at the end. Okay?
This is my excuse for studying.
Okay, then remember, dy dx is your first derivative. And remember that determines your slope. And remember, that can tell you also if it's increasing or decreasing based on the sign. Then d squared y dx squared, that's your second derivative. And that determines your
Concavity.
Yep. Concavity. So if we were doing that first one, okay, here's how you know if you're doing implicit or not. Look at number 1 and then look at number 2. Okay, what do you notice is different about the questions?
The one has a y.
Yeah, this one, the y is already by itself. That's not implicit. That's just a normal derivative. Okay, versus on this one, do you see how the y is in the middle of the x stuff? Okay, so that's the difference. This one is just normal. This one is implicit. Okay? Implicit differentiation. Okay, so let's do this one first. What rule do we need? Product rule. Very good. So that's my u, that's my v. U is going to be cosine x. V is going to be e to the 2x. Then what is u prime?
Negative sine x.
Yep. And then what is v prime?
Same thing.
E to the 2x times 2. Remember that extra 2 comes from chain rule. So then your dy dx here would be cosine x 2e to the 2x plus e to the 2x times negative sine x. And remember, the order there is not really necessarily specific. You just want to make sure you do one plus the other. Okay, then from there, what do they both have?
E to the 2x.
So e to the 2x needs to be factored out. What would be left over?
Negative sine x plus 2 cosine.
Yeah, so I'm going to put my 2 cosine x first just because that's the order that I wrote it in. And then my minus sine x would be left from the second one. So which one do we want there?
D.
Yep, D. Good. Okay, next one. This one's going to be implicit. Where am I going to need product rule? Which term? Xy squared. Very good. So my u is going to be my x. And my v is going to be my y squared. So if u is x, what is u prime?
1.
If v is y squared, what is v prime?
2 dy dx.
2 what?
I'll look at the thing and answer it.
That's what I had.
Yeah.
That's really nice.
2y dy dx. Okay, then from there, for that particular thing, you're going to have to do x 2y dy dx plus, and then 1 times y squared. Then equals, what's the derivative of 3? 0. And then equals, what's the derivative of sine x? Okay, then remember, anything without a cosine x has to move to the other side. What's moving? Y squared is going to move over, which will make it what? Okay, so cosine x minus y squared. And then on this left side, I'm going to keep my dy dx here, but I'm just going to reorder this front term to be a 2xy. And then if those are multiplied, how do I solve? Good, so we'd take our 2xy, divide it to the bottom. Which one would we be looking at? Yep, D. All right, turn the page. Okay, next one. How many product rules are we going to have to do here? 2. You're going to have to do 1 on this side, 1 on this side. For my first one, my u is going to be x, my v is going to be y squared. What does that make u prime?
1.
And v prime?
2y. dy.
Yep. Yep. 2y dy dx. Okay, then on my other one, I'll try to, I guess, squeeze it in up here at the top. Okay, what is my u going to be?
3x. Negative 3x.
negative x cubed. Remember, if there's a minus, it will make your life easier to just squeeze that into the product rule. So then my v would just be y. So then u prime would be what?
Negative
3x squared, negative 3x squared. What about v prime? Okay, then remember, I'm going to have to do this product plus that product equals, what's the derivative of 6? 0. Good, so let's do this one first. I'm going to have y squared plus 2xy dy dx. Y squared plus 2xy dy dx. And then on my next term, do you notice that both of them have a subtraction? Each diagonal does, so they're both going to have a minus. So I'll do this one first, minus 3x squared y, and then minus x cubed dy dx. Equals 3, or 6?
Instead of putting positive, you put negative.
What was that?
You said 1.
Oh, gotcha. And then on this side it would be a 0, because remember, the derivative of 6, which is a constant, is 0. Then from there, anyone that does not have a dy dx has to move across. That's this one and this one. When they switch to the other side, make sure you reverse their sign. So it's going to be a positive 3x squared y and then a minus on the y squared. Okay, the other thing we have to remember to do on the terms that are left over is you'll notice that they both have a dy dx, so I can factor that out to the front. Does this all look pretty familiar?
Yeah.
So your 2xy is going to stay from that term. Your minus x cubed is going to stay from that term. And then from there, you would divide that part to the bottom. Hey, Trixie.
It's Trixie.
So then that's going to end up down here, 2xy minus x cubed. Okay? So look at it. It says, show that that's true. Boom, we did it. Done.
Yeah, so where does that left,
This,
more left?
this,
Yeah.
Yeah.
Why do we have that and the one on top?
because you had one product here and then one product here. Does that make sense? So this is the first product rule, and then that crap up there is the second product rule. Okay?
Let's do that to you. Just that.
Yep. Okay. Next one, find all the points where the x coordinate is 1. What do I use for points? The original or the derivative? Original. So go back to here. We had xy squared minus x cubed y equals 6. And they're telling me I want my x coordinate to be 1. So I'm going to plug in x equals 1 and find my points. So if x is a 1, that's just a y squared. X is a 1 here, that's just a y, equal to 6. So I'm plugging in x is 1. Okay, I'm going to factor that. Y squared minus y minus 6. So how could I factor that? Negative 3 and plus 2. Which means that this is important. My x value is 1, but if I got 2 different y values, how many points do I have? 2. So one of my points is going to be 1, comma 3. And my second point, very good, is going to be 1, comma negative 2. Now, how am I going to find the slopes that go with those points?
Plug in the numbers with
Yeah.
the slope.
You're going to plug in right up here. So let's say I'm doing 1, 3. Since this is a free response, we're going to put dy dx at, and then put your line and your 1, comma 3. Note it because it says write an equation for the tangent line at each of these points. So we're going to have to do 2 tangent lines. And so then our first one on top, we'd have 3 times x is 1 squared times 3 minus y squared would be 3 squared. Divide by 2x is 1, y is 3 minus 1 cubed. Look just at the top there. What am I going to get? 9 minus 9 is... So that tangent line is going to come out pretty easy, right? If my slope is 0, it's y minus 3 equals 0x minus 1. Now, if this side is a 0, you could just only put a 0 because the x minus 1 multiplied by 0 would cross out. But you don't have to, but you could. Okay, second one, dy dx at 1, negative 2 equals, and then we're plugging in using our dy dx right here.
Do we have to do, like, you know how you get a point and then the slope?
Like, would you have to write the point?
No. So you know how you have point and underneath you're solving the slope?
Yes.
Do you have to do it that same format?
No. And then from there we have, okay, so that's 3x squared y minus y squared. And then divide by, and then on bottom we have 2xy minus x cubed would be 1 cubed. Okay, and then looking at this top one, 1 squared is just 1, so I'm going to cross that out. What's 3 times negative 2? Negative 6. Now, over here, what do I do first? Can I cross out these negatives? No, can't do that. Remember PEMDAS, right? You have to do the squared first. What's negative 2 squared?
4.
And then minus 4. Okay, so make sure, I actually put this on a test a while ago, and several of y'all tried to cross those out. Then on the bottom, what's 2 times negative 2? Minus 1 more? Negative 5. On top, that's a negative 10, because it's negative 6 minus 4 more. What's
Positive 2.
positive 2? So that came out to be a 2. And then I would write the equation of my tangent line, y plus 2. 2 is my slope, x minus 1. Got it? Okay, last thing. We want to know, find the x coordinate where the tangent line is vertical. A vertical slope, where should your 0 be? On the bottom. Remember, vertical is undefined, right? Vertical is an undefined slope. And if you want your slope to be undefined, that means the denominator needs to be equal to 0. So I'm going to set my 2xy minus x cubed equal to 0. So if you want a vertical, you're setting the denominator equal to 0. Now we're going to have to do a substitution here. Which letter will it be easier to get by itself?
Y.
Y, because there's only one y versus having two separate ones. So I'm going to add my negative x cubed across. So 2xy is now x cubed, then I'm going to divide by 2x. What is my substitution going to be for y then? If I have x squared and I divide by an x, what's that? Or, I'm sorry, I said that wrong. X cubed divided by x. X squared, and I'm just going to put a 1/2 in the front. And then where could I substitute that in? I already used the derivative. What else do I have? The original. Yeah. So I'm going to come back to right here, and I'm going to substitute that in for where my y is. So it would be x times 1/2 x squared minus x cubed y is a 1/2 x squared.
Why are you doing that?
Yeah, I don't think there should be a square on that first parenthesis. Right?
X.
No. There's
the original.
The squared's right here.
That.
Yeah?
My question is, why are you using that equation again?
Because so we want this to be equal to 0, and if it doesn't give you a number, then you would have to treat it like a system of equations. So you would have to say, okay, what else do I know about x and y? Well, I know they have to fit this equation. So you would solve to make the bottom 0, and then plug in right here. Okay, so we're plugging this in, can put here, plug into original equation. So what is 1/2 x squared squared?
1/4.
1/4. And if it's x to the 4th and then this little guy, can we just make it to the 5th? Yeah? Okay, then on the second part I have a 1/2 in the front. And then I have an x squared times an x cubed. What's that? And then a 6. And then to get rid of those fractions, unless you just love fractions, times everything by 4. What is 4 times a 4th?
You put the
Gone?
6 of 5.
Do what?
X to the 5th, that should be 6, right? No.
Because you're adding. Remember, if they each have their own x, you're adding the exponents. Okay, and then what is 1/2 of 4 here? 2x to the 5th. Can those go together? Okay, I'm going to change that 6 to a 24. What is 1x to the 5th minus 2x to the 5th? Okay, and then can I keep the negative there if I'm going to take a power? I'll have to multiply by -1 now. Negative 24, then what?
This 5 root of.
Yep. Can you 5 root a negative number?
I don't know.
Yeah.
Yes. Remember, if it's a square root or an even root, you can't. But if it's an odd root, you can. So it'd be the 5th root of negative 24. Now, that's or is it -2? No, it's not. It's nothing. So you just leave it like that.
Is it
Yeah, no, it'd be 32 if it was perfect. It would have been the 5th root of 32, but it's not. So you just leave it like that. And notice you only have to find the x coordinate, right? Now, if it said find the ordered pair, you'd have to take that, plug it back in over here. But thankfully for this one, since it's not a pretty number, they didn't make you do that. Got it? Okay, turn the page. Okay, one more kind of like that, number 6. This time you have to write the equation of a tangent line at 3, then use it to estimate f at 3.2. Did I count it wrong?
I was like, I'm turning the page wrong.
Oh.
You
No one
lucky
knows. No one
hoe.
knows.
Hey, you numbered it right though.
Thank you. Okay, we're setting the bar low here. Okay.
Yeah.
Yeah. What do we need for the equation of a tangent line?
Yeah, like when you said number 6.
Okay, look, I'm going to bring you a little treat, and will you just do that first one? So what you have a point, what do you still need?
That's the
Slope, then a tangent line, and then you're going to plug that decimal in. You can do all those steps, right?
Oh my god, not me.
Do you want a cookie or cheese balls?
I want a
cookie.
I would like a cheese box.
Oreo.
Okay, so you said that.
They're all in the same package now.
You said if I finish this and then give it to you tomorrow, you'll sign it for me?
Yeah.
Yeah, it's really a habit now. Okay, and wow.
I want Chips Ahoy because Oreos
your
cause
work.
cancer.
Yeah.
Really?
Yeah, good work.
Hey, Helen.
Yeah.
I
Make sure
mean,
Oh, yeah.
If you're eating an Oreo, you're gonna get cancer.
I think shut.
I don't want you guys to know that you're gonna get cancer if you eat. Yeah, a whole bunch of people got like they're leaving
You know
the
what?
company
Everything
because
we
a lot of
eat and
people.
do have cancer in it, okay?
No, but they're getting
Not-
cancer from making Oreos, which means that they're putting unnatural chemicals in it. You're eating unnatural chemicals.
Girl, that's
You're
every
gonna
food
die.
you ate in your life.
I bet you.
You're
She
gonna
bought
die.
packaged at the store.
Actually, I started eating at Whole Foods.
Eye roll, please.
Started eating at Whole Foods.
Okay, what's the slope?
DYDX bar at 3, 1.
Okay, now, and do you notice you never use the x? That's okay. If it's only got y's in it, you only use the y. So then I do y minus 1, 2, x minus 3. Okay, I'm assuming you could do this part. 3.2 minus 3 is 0.2. 0.2 times 2 is 0.4. Then what do we do with the 1? Okay, so it'd be 1.4.
Adios.
Bye. Okay, second part. What is the value of d squared? Oh, that's me. I was like, how is it so close to me? Okay. How do you find d squared by dx squared?
Take another derivative.
Good. So here's my original derivative. I'm taking the derivative one more time. So that'd be d squared y dx squared.
2y plus 1.
Yeah, so if it was a y squared, the derivative would be 2y what? dy dx. Good.
And so, okay, if it says x equals 1, that means y would still be 1, right?
It would be 1 and then what? dy dx. Yeah?
No. I mean,
But yes, you're right. It would just be the 1, but then you'd put a dy dx on it because it was a y thing instead of an x thing.
I messed up my question.
Okay, ask your question again.
X equals 3, that means your y would still be 1.
Correct. Yep. So at x equals 3, we already know 3, 1 is the point. So then I would be plugging in my y is going to be a 1. And what is my dy dx that I already found? 2. Then dy dx here is another 2. So 2 times 2 is Plus 2 is 6. Good. Now, if that is the value of the second derivative, part C says, is your linear approximation greater than or less than the actual value? Remember, that's concavity.
Concave up, so less.
Okay, therefore, it's concave up, and it is less than. Okay?
Hell yeah!
Now, what mistake, if this was free response, did I make in part B from here to here? What's the difference?
You didn't label it.
Yes. Okay, this has to be labeled. Otherwise, you're saying that two things are the same and they're not really the same. Okay, one of them is a formula, one of them is a specific number. Okay? All right, last one like that. What is the derivative? Actually, first question, is this going to be implicit or a normal derivative?
Implicit.
Implicit, because where are x and y? They're together. If y is by itself, it's normal. But if x and y are together, that makes it implicit. So what's the derivative of sine? Cosine xy. And then I have to multiply by the derivative of xy. What rule is that going to need? Sad day, product rule. Okay? So when I do my chain rule, I'm going to have to do product rule in the middle of it. So my u is x, my v is y. What is u prime? What is v prime? And then when I multiply, I'm going to put a bracket here because I'm multiplying cosine x by the middle derivative, which is kind of longer than usual. So it would be x dy dx, and then plus y. On the other side, it was an x. What's the derivative of x? 1. Good. Okay, from here, you have a couple different choices. I want to get dy dx by itself, yeah?
Yeah.
Okay, so what you could do is divide this across, subtract the 1, and then divide by x. Here's the problem with that. You're going to end up with fractions with different denominators. If you're good at that, that will work. If you're not good at that, this is how I would do it. Distribute the cosine x in. So it takes a little more writing, but you're not going to have to get a common denominator later. X dy dx. And then on the second one, I'm going to have a cosine xy times a y. So that way, I can just subtract the crap across like we always do, and then divide the other thing across, and then you're still done. So this whole term is going to move across. What sign will it have when it goes across? It'll be a minus. So cosine xy x dy dx equals 1 minus cosine xy times an extra y. And then I'm going to end up dividing by cosine xy. And this extra x. Make sure you got to divide by that whole thing on the bottom here. So it'd be cosine xy times an extra x to cross that out. Helen, you look confused. You sure? It would know C. What's wrong with C? Doesn't have that extra X. Remember it was here? Right here?
I forgot to write it.
Yeah, so it would have to be D. Right?
So,
1 minus y cosine xy over x cosine xy. And the trick answer here would be, it'd be really easy to forget about this little x here. But remember, if they were together, they're ride or die. Okay, they're sticking together till the end of the problem. Okay?
I thought the bottom cosine xy crossed out with the top.
Oh, it actually can't do that. That's a good question. The only way that could work is if both things on top had one and you could factor it out. Then you could cancel it out. Like, think about this. If you had this 2 plus 3 over 3, can I just cross out the 3's and get 2? No, would that be 5/3? That's not the same. Okay. All right, last thing we have to cover is related rates. Yep. This top one here, I was going to have us do it just as review, but the only thing about it is, y'all remember, if this is a dy dx, that's a differential equation. You would integrate on both sides. But we're doing a session on that later, so I don't want to get caught up on it today.
Can we go back to 5 real quick? For 5, why do we do y? like cosine and then the thing in the bracket?
Because it's chain rule. So you take the derivative of sine and get cosine, but then you have to times by the derivative of xy in the middle. And taking the derivative of xy, you have to do product rule. Okay? Alright, so go to FGWE. Okay, remember it's find, given, when, and equation.
Oh man, I love these.
No, I hate this.
This is too long.
Okay, and then remember that when you take the derivative with respect to time, every quantity that is not a t is going to leave behind a d something dt. So if it was a q, it'd be a dq dt. If it was a v, it'd be a dv dt. Okay? Now, this first one is not so bad as long as you know what you're doing. You have w, x, and y are differentiable, and then you have this equation. Then it says x is decreasing at a constant rate of 1 blah 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 per minute. They just gave us dx dt. So find, given, when, equation. What did they give us?
dx dt
And is it 1?
1 per minute. So negative 1.
-1. Why negative?
This is decreasing.
Decreasing. Very good. Y is increasing at a constant rate. What's that?
Positive 4.
dy dt is +4. Then it says, at what rate is w changing? Well, then I want dw dt. That's the same as w prime. Some teachers actually would abbreviate it that way. Okay, and then we want to know when what?
When x equals 6 and y equals
Now, what letter did they leave off?
w.
Can we find it, though, if we know this?
Yeah, because you have
Yeah. So I'm going to pause right there and say, okay, well, w equals x squared, which is 6 squared, times y, which is 20. So if x is 6 squared, what's that?
36.
Okay, 36 times 20. What's 36 times 2?
72.
And then add an extra 0, so z is 720. So 36 times 2 would be 72, then add your extra 0. Okay, my equation, I'm just going to put here, w equals x squared y. And now remember, the point of that equation is we're going to take the derivative with respect to what, though?
x equals z equals.
Huh?
This would be w equals, not z equals.
Yeah, I was
Oh.
say. Like, where did you get the Z?
Oh, that makes sense.
Z was more for fun. Z for zebra. Okay. DDT, yep. And remember, when you do it with respect to time, anything that's not a t leaves behind one of those. What's the derivative of w then?
dw dt.
dw dt. And on the other side, what rule are you going to need?
Product.
Product. Very good. So my u is going to be x squared. What does that make my u prime? 2x what?
2x dx dt.
dx dt. Then on my other side, my v is going to be a y. Derivative of that is dy dt. And then from there, you'll do your cross product on the other side. So it'll be 2xy dx dt. Sorry, I said that wrong. 2xy dx dt. And my other one will be plus x squared dy dt.
And then you solve for it.
And then from there, you just be plugging stuff in. Okay?
Yeah, 6 times -1.
Hey, you can do that later for fun. Okay? Turn the page. Just since we started kind of late and I don't want to keep y'all super after. Let's just try to finish this. Maybe. Yeah. Okay. Look at number 8. Okay, we have a find, given, when, and then I'm just going to mark E will be one of those two. Okay, we have to pick which one, but we'll pick in a second. So an ice sculpture in the form of a sphere melts in such a way that it remains in spherical shape. The volume is decreasing at a constant rate. What are they giving you?
dv dt
Okay, dv dt.
equals -2 pi.
And y -2 pi.
Decreasing.
Decreasing. Okay, then it says, at what rate in meters per hour is the radius changing? What will we be finding? dr dt. Okay, and then it says at the moment when the radius is 5. Okay, so if I know about the radius and I know about the volume, which of those equations are we going to use? Nope. V, yeah?
Why?
Because V and V, yeah? This is area, right, for the S is surface area. So V equals 4/3 pi r cubed, and then we're going to take the derivative. What's the derivative of V? Okay. And then on the other side, I would multiply my 3 down, and the 3's would what?
Cancel.
So 4 pi r squared, done?
dr dt.
Yes, dr dt. Okay, then from there you'd be plugging stuff in. Our dv dt is a negative 2 pi. On the other side it'd be 4 pi.
From office. All control and from office, please.
Yes. Okay, then from there, what's 5 squared? 25 times 4? Okay, so that's 100 pi dr dt.
Remember area.
And then what?
Divided by 100.
Just 100? 100 pi.
And so that's negative 1 over.
Negative 1 over 50, yep. So dr dt equals negative 1 over 50. Okay, next one. At what rate in square meters per hour is the surface area decreasing at the moment when the radius is 5? Okay, which of my equations would we be using now? S. Now notice all the other stuff is the same, so I'm not going to rewrite it. Okay, surface area is here. 4 pi r squared. What's the derivative of S? Yes, dt. Other side times the 2 down. 4 times 2 is 8. And then times dr dt. And then our r was a what? 5. Yep, we're reusing this info right here from the other problem. So ds dt equals 8 pi, r is 5, and then dr dt was negative 1 over 50. What is 8 times 5? 40. So I have 40 over 50. I forgot to write my pi, and it is negative. Yep. Okay, so let's first reduce that to be what? 4 over 5 pi. Okay, now, if you look at the way that it's worded, it says, at what rate is the surface area decreasing? So did they already mention that it's decreasing? Yes, so it makes sense we got a negative, but the rate would just be 4 pi fifths. Okay?
So that's it.
Yep. Okay,
We're not gonna do that.
I really just want to do one with trig. So turn to the next page, and let's just do letter D. Okay? So look what it says. You have dx dt is negative 2, and then dy dt we would have found. So we really kind of need to just do the whole thing, but I know y'all don't want to do that. So we'll just finish that last one and then be done. And then I'll work it out in here, and if you want to try it, it'll be in the binder with all the other answer keys. Okay, so look at your tank. I'm going to have to redraw mine since I drew all over it. Okay, we have our radius, and then we have our height. What does it tell you about the shape of it? The diameter and the height, they're both 20. So this is 20. And then do I care about the diameter?
No, you need the radius.
I need the radius, which is 10. Okay, then it says when the volume is increasing, find given when. What did they just give us?
When the derivative is positive.
Okay, so the volume dv dt is increasing at 24, so positive 24. And the height of the water is 4, so height is 4. Then it says, at what rate is the height of the water changing? So we're finding dh dt. Now look at the equation they gave you. 1/3 pi r squared h. Do you notice that it has a v? We know stuff about dv dt. It has an r and it has an h. We can only use one of those letters. Which one are we more interested in? We're finding dh dt. So that means that h is the letter I want, r has to go. This is where you have to do a proportion. Okay, so draw your water in, let's say it's right here. Draw in your r here for radius, your h here for height. What proportion could I set up for r and h? What is r similar to out of my numbers? R over 10 equals, and then I'd have to do h over 20. So I'm putting the radius and the height matched up with the corresponding sides of the tank. And then from here, I'm going to solve for r. So what would I do with this 10 on the bottom? 10h on top. So r equals 10h over 20. Can we reduce that? Let's just make it half of h. And then I would take that, plug it in right there. Now again, why are we doing that? Because we're interested in h, we don't care about r, and we don't know anything about it. So it'd be 1/3 pi r squared h, and then where my r was, I'd put a half h in. What's a half squared?
1/4.
What's a fourth times a third? 1/12 pi h cubed. And then from there, I'm going to take the derivative. But remember, you want to kind of make it together, simplify it first. So times your 3 down. What's 3 out of 12 the same as? Oops, I forgot to write dB dt. 1/4 pi. And then h is now to what power? Squared times dh dt. And then from there, we know lots of stuff. What's our dV dt? 24, 1/4, and it was a positive 24, right?
Yeah.
And then our h squared is a 4 squared dh dt. What's 4 squared? 16 divided by 4. So I have 24 equals 4 pi dh dt. Oh, I made this question. I forgot to put the pi in there. But what would we have to divide by now? 4 pi. So what's 24 divided by 4? 6 over pi. There you go. Big A. Okay? All right. Good job. So remember those last questions. These are to benefit you for the AP test. The answer key will be in the book tomorrow. You can check the other ones, but you have your signature for being here today. Okay?
Hey!
Oh, sorry.
No. You want to give you my paper?
Yeah. There you go.
Did you change the band color?
And then, Justin, do you have your purple sheet?
Probably, yeah.
Okay. If you don't, I have more behind that binder if you need one.